Standard Industrial. We created a series of tutorials to make sure that you have the information needed to get the most out of your Standard Industrial equipment. When you're done with these lessons, check out the other skill building videos on our YouTube channel, and thank you for choosing to make Standard Industrial part of your business. In this lesson, we're going to learn to create a numeric program. Numeric programs should begin on the editor page, so to access the editor page, we want to select the icon that contains a sheet of paper. You'll know you're on the editor page by the label that appears in the upper left-hand corner. The editor page is organized in four major areas: the piece informations area, the general data area, the angle information area, and the work information area. To create a new program, select the New Program button, select New Numerical, select Confirm, and we'll begin to enter information about the material that we're working with. First, we'll enter width information. The width of your workpiece should be entered in inches, so for a 4-foot wide workpiece, we'll enter 48 inches. The thickness of your workpiece should be entered in thousandths, so if you're working with 10 gauge, 0.135 would be correct. Next, we'll select the hardness of the material. When you click on the hardness field, you'll be presented with a list of materials. Each of these materials has a number following it, and that number represents the ultimate tensile strength of the material. So in this situation, we see a steel that has a 48,000 psi ultimate tensile strength, but we have options for other steel that has 37,000 psi tensile strength. If you don't see the exact material in the list that represents the material you're working with, then select the material that has the ultimate tensile strength as close to the material that you're working with as possible. In this case, we'll select steel 48, and the label will be inserted into the hardness field. The station field value can be left 0. In this situation, we're not working with multiple stations on the press. We'll cover that in another lesson. Next, select the die field, which will present you with a list of the dies that are available for your use. You'll want to select the die you want to use for the bending operation by highlighting it, and then select the Insert button to insert that label into the die field. Next, we have the V-die field. The V-die field is used if a 4-way die has been depicted in the machine. Standard Industrial feels that it reduces the potential for operator error to enter each face of a V-die as if it were a single-face die. So we don't depict 4-way dies in the control, and as a result, these fields will not be used. Next, select the punch field. The list of available punches will be presented. Highlight the punch that you want to use for this bending operation, and select the Insert button. Next, we'll move on to the angle information. The y-axis represented here as Y1 and Y2 are the round cylinders. And because we have 2 cylinders on this control, we recognize that it is for a Standard Industrial EV model dual cylinder press brake. If you were working with a Standard Industrial AB model single cylinder press brake, only the Y1 axis would appear. The angle field is where we're going to enter the degree of the angle we're trying to bend. So in this example, we'll say a 90-degree angle. You'll notice that the control automatically populated that same angle value into the Y2 axis. That's because by default, the control assumes that we're trying to bend an even angle. In actuality, these can be set to different values if, for instance, you're trying to bend a taper or a cone. But for this example, we're going to be bending an even angle, so we'll leave both values set to 90 degrees. To the right, you'll see fields labeled LDC, and you'll notice that once we entered the angle information, a value for the LDC was automatically populated. The LDC indicates the position at which the ram has to reach in order to achieve the bend angle that you've specified. So to reach a 90-degree bend with this material thickness and the tooling that we've selected, the ram is going to have to reach the position of 9.185. Also, you see these fields, which are the correction fields. The correction fields allow us to make fine adjustments to the bend angle, and we're going to discuss how to enter corrections in a separate lesson. For now, we'll leave both of those values set to 0. If your press brake is configured with a back gauge, the x-axis fields will be present on the editor screen. The x-axis represents the back gauge position and controls the length of the bend. To set your bend length, click on the final field and input the length of your bend. In this example, we'll choose 4 inches. The length of our bend is now set at 4 inches. Next to the final field that controls the bend length, you'll see the retract field. The retract field controls the distance that the back gauge withdraws once the ram has reached the pinch point. The back gauge retracts to provide clearance for the material as it moves upward during the bending process. To set the retraction distance, click on the retraction field and enter the distance you want the back gauge to retract after the ram reaches the pinch point. In this example, we'll set 60 thousandths of an inch, so 0.060. Now the back gauge is set to retract 60 thousandths of an inch to allow for the metal to clear as it moves upward during the bending process. To the right, you'll see also a corrections field for the x-axis. You'll notice that this value is automatically populated, and it's based on the material thickness and the punch being used. While this field is manually changeable, it's not usually necessary to modify it, and we'll cover entering corrections in depth in another lesson. The R-axis represents the height of the back gauge. If your back gauge is configured with a powered R-axis, then this field will be present on the editor screen. You'll notice that the value is already populated automatically by the control. Because the control understands the height of your tooling and also the thickness of your material, it automatically calculates the height of the back gauge. As long as your back gauge is calibrated correctly, this value should be correct and should not need to be altered manually. However, if for some reason you do want to manually alter the height of the back gauge, simply click in the R field and program in the manual height that you would like the back gauge to achieve. So at this point, we've populated all of the information necessary for a numeric program. We've told the control the width of the material that we're working with, the thickness of the material we're working with, the type of material that we're working with. It also understands the tooling that we're utilizing. It knows the bend angle that we want to achieve. It understands the bend length we want to achieve, and it has calculated the R value, or the height of the back gauge necessary. Take note that it wasn't necessary to modify any of the settings in the work information or piece information area in order to complete a numeric program. The information in these areas helps us tailor different characteristics of the bend, and we're going to focus on those in separate lessons. But in order to create a numeric bend program, modification of any data in the work information section and the piece information section is not necessary. At this point, we could go ahead and move into a production mode and execute our bin. However, the bin hasn't actually been saved. So before we execute the bin, we'll go ahead and save by moving our cursor to the icon that has the computer emblem on it and clicking here. The name screen will appear, and here we can give our program an alphanumeric name that's up to 30 characters long. So we'll call this program StairPen. We'll click OK, and when we do, we'll notice that StairPen appears in the name label of the Numeric program. To double check that the save occurred successfully, we can also go look in the program's database. This icon that contains the computer symbol for database and also a symbol for the sheet of paper for the editor is trying to communicate to you that it is the program database. So if we click here, it will reveal the list of programs that have been saved, and here we see StairPen, so we know our program was saved successfully. Next, all we need to do is move into one of our production modes, either semi-automatic or fully automatic, and execute our bin. Because executing a bin involves selecting the correct production mode and also using the hand controls on the machine, we're going to cover that in a separate lesson. Standard Industrial hopes that this tutorial has been helpful in developing your press brake operation skills and invites you to use the other materials in our educational library. If you have questions about Standard Industrial machinery, please contact us at 662-624-2436. Thank you.
I hope this tutorial has been beneficial, and if it has, we need to ask a favor of you. In order to keep this site visible and to continue to bring this material to you for free, we need you to become a subscriber. We promise if you do that we will not send annoying solicitations to you. The only time you'll receive notifications is when we post new material to the site. So please subscribe, and thank you again for choosing to make Standard Industrial part of your business.